Okay, so on the test stand right now, you will see we have 0-second unit. It's at 183 degrees currently. It is running on its low speed position. We're gonna go ahead and switch to off. You can watch it stop like it's supposed to. That's where a lot of them fail, and the engine and the after treatment overcools. All right, so now we're gonna switch back on low speed, just the way the bus would do it. And now we're gonna go ahead and switch up to high speed. And I will work it back and forth so you guys can watch it work. Low speed, off, low speed, and off, and high speed. Back to low speed, back to high speed, back to low speed, back to high speed, low speed, and we're gonna leave it on high speed now. All right, you can see we're climbing up there in the temperature. So we don't want to get higher than about like 190. So what I'm going to go ahead and do is lower down the temperature now. Okay, so we just got a light little bit of heat being applied now. And the reason we do that is not just to keep it from going too hot, but now we're going to start slow cooling it, just like it would in the bus. It doesn't cool off instantly, so we like to heat it up slowly. And the way we start this process is just running the clutch with nothing engaged to warm up the bearings inside. And then we will engage low speed to slowly warm up the gear oil temperature and get the oil distributed properly in there. And then we will engage high speed, and then we'll cycle it back and forth to break in the clutch plates properly, because we resurfaced them and shim it up to where it is, it's got a good air gap, but it's not too far, so it doesn't end up cracking the springs like a lot of them did early on. So there's a lot that goes into building these properly, a lot of like tuning factors. So we're very careful about how we test them, not to shock it thermally or mechanically. All right, so it's going to begin its slow cool down process now. In about, I would say 10 minutes, we're going to go ahead and shut this heater off, and then we're going to let it continue to run, and we'll cycle it between low, high, and off to kind of even out the temperature throughout everything, including the coil. All right, so without too much further talking, I want to show you guys that the emergency bolts are here. So if you want to stash those on the bus, there's like a plate that goes right here in the bus when you mount the fan clutch, and there's 4 holes there. That's where your emergency bolts are supposed to be. So I would take them out of there because they would be blocked by a heat shield. We just put them there so that they're with the clutch. All right. So moving on with the testing, real quickly, we just want to show. We are running 27 volts, currently drawing about 1.6 amp and 44.30 watts. You could watch some of the other videos and compare, and you'll be able to see that those are normal numbers. All right, and then when we switch it over to low speed, you see that it has changed, right? And now we're running 0.6 of an amp and 17.41 watts. Now I'll switch it while you're looking at it. Back up to high speed, and you can see it's about an amp more draw on the high speed side. Okay, so now we'll go to off. Okay, and we'll kill the power, because you can't ohm anything with power connected. And you'll see that we are ohming the coil with more resistance. So the coil with more resistance is obviously going to be the one that has the lower amperage draw. Okay, so let's check that out. Okay, so we'll turn the power back on, turn that off to protect the meter. Okay, and we'll go on low. Okay, so you can see lower amperage draw on low, higher amperage draw on high. So inversely then, low being lower amperage draw, switch that to off. We can clearly see then that the higher resistance is going to be the one with the lower amperage draw, right? Less flow through the coil. So that's our low speed coil right there. All right. Normally they ohm about 34 to 38 ohms cold. And we like to see them gradually increase in resistance as the temperature increases, which is what we've seen here. And then we'll go ahead and switch this out to the high speed side. Okay, and you will see that it's got a lower ohm reading. All right, about 16 ohms. And cold, that one's about 13 ohms or so. 13.8 around there. So we're seeing normal readings from this hot, cold, and operation. These two coils were the ones that came with these units that Cyril gave me to go ahead and rebuild for him. Here is the numbers from everything. This 3204, that's our company serial number for it. 031051, that is the gear case number. And then J7307729.1.1, that's going to be the coil serial. So we're documenting everything on these builds because not because we've had issues with this company per se, but you know, there's been a couple instances where people have, you know, tried to get over on us and, you know, swapped parts around and said, well, look, it's yours, see, and it turns out that it's not. And we can verify that when we take them apart. Not only is it kind of heartbreaking to know that you're doing business with someone that's going to do you like that, but, you know, it's just, what's more heartbreaking is the insult to our intelligence here, that we're not smart enough to serialize our parts, right? So, you know, please don't, you know, take apart the units, don't try any funny business if you're watching this video out there. Not you, Cyril, not any of these guys that I normally deal with, but, you know, occasionally in business we come across customers that will try to do things like that. So we have to protect ourselves and also protect the purchaser's interest in this as well. So this is why we, you know, do things like we do here with taking a good look at the threads. Right? So those threads are good. These threads here on the front are obviously good. Our pulley is held on by those. And then we can go ahead and remove the little doghouse cover we made here. Stash that over here to the side. We got that fan there cooling the motor because there's so much heat in this area. And you can see these threads are nice and clean, and the threads at the bottom, that's what's holding it on to the bench. And we can see that there's no leakage or anything like that. It's kind of toasty over here with the heater running, so I think we're going to go ahead and shut the heater off now, and then we can go ahead and let it do its slow cool down. All right, so also a little dangerous to do with it running, but I'll still do it because I like to live on the edge. We'll unplug this and we'll show you we're using the same connector that the bus uses. We'll show you the condition of the coil connector. There's no corrosion, there's no debris, it's not cracked. You know, we just want to be very clear about this stuff, okay? And we actually epoxy these so that they're sealed from the top where water would get in for pressure washing and stuff like that. We try to make sure that that can't happen to you guys by sealing it with epoxy and stabilizing the connector. All right, so she's good to go. We're gonna continue running her for the slow cool down. Keep that oil circulating inside. We are going to drain the oil. We don't ship them or deliver them with oil, but let's go over here to the packaging. Okay, and you'll be able to see if I can open it one-handed. Okay, we've included the oil there in the corner. It's gonna be well padded, and then this QR code is a link to all the documents, the warranty documents. You will find diagrams with torque specifications and all that for installation. So you'll be quite pleased with that. Not just torque specifications, but the entire installation procedure as well will be available on there. So thanks for watching. If you have any questions about what we do here, feel free to reach out on the website. That's pravolte.com. All right, or feel free to give us a call at 1-877-390-3260. Thank you for watching. We appreciate you guys. We appreciate you guys over there, Stormtrooper, Cyril, all those guys down there do a great job, and our regular customers, and we really appreciate the business. Thank you.